with my ability.
Well, I'm sorry for those of you joining us online. I forgot to hit go live.
What are you doing this on? Is this on Zoom?
This is on YouTube.
Oh, yeah, what was it?
It's on the website.
Oh, yeah. No, but what are you recording with?
Oh, I use OBS.
Okay.
I use OBS. Yeah. I mean, if you, right?
No, not yet. Oh.
There's OBS.
Yeah, no, I see.
Yeah. So, and now they see. Yeah. So anyway, I apologize to those of you who might be joining us or wanting to watch this live session. I forgot to hit the go live button, but this is session 24 on beams, and it's the beams 5. And technically speaking, all I was talking about is how we have these relationships between the deflection along the beam, moment, shear force, applied distributed loads. And if you use our two big equations that relate internal moment to shear force and shear force, internal shear force to applied distributed force, you can take the derivation that you see in the notes and then get these other expressions. This session is particularly complicated, I think, mathematically, at least algebraically. Okay, it's not high-level math, but there are a number of places where I will make mistakes. Maybe you won't make mistakes, and so it requires some critical checking, boundary conditions, integration, and knowing the conventions. Right? And the new conventions that we introduce here are what is positive slope, and when we say slope, we mean deflection as a function of, deflection, the derivative of deflection with respect to the x direction, and also what is positive deflection. So we think of positive deflection, okay, in Hibbeler's terms, okay, where we will say that
If you don't mind me asking, what is that a scooter?
No, it's from a bike.
Oh, it's a battery.
we're looking at
Giant water pump.
oh, did I not have it? Well, this is deflection.
That's cool.
Okay, upward.
Yeah, it's basically. Can I get my answer?
Yeah. So I'm working on it. I'm gonna give them back as I can. I need to scan them first.
All right.
Question 3. I have no idea, dude. Let me see. That's the question.
You're really good with it.
Okay. Stop.
you know how to do this stuff? This is just question 1 of 23.
No, I'm done, yeah, I didn't do any 23, I did 1 and 2 and 22, but.
Okay.
I didn't get 1 and 2. I didn't question 3 or 22, cause like, yeah, I got.
Dude, number 1 is matching.
What?
Number 1 is matching.
Yeah,
That's fine. I'm gonna learn 23 and I'll see if I can figure it out for us.
I don't know. I was looking at it yesterday, but I was like 11:30 at night, I just wanna go to bed to wake up, I got to wake and remember this shit yet, so I'm just like, no, I'll do it later.
Okay, so the maximum is. Oh, I think I can do this.
It doesn't seem that bad though, like when you go at it, it's like,
Yeah.
it doesn't seem that bad to look at though.
Let's see.
So it's like a negative separation.
Sorry.
Did you do 22?
What's up? 2. I only did the like a half.
Dude, he's not very good at this.
What did he
So
say?
I'm assuming we plug the numbers, and I'm assuming the second stress would be 0, right?
Let me pull it up. Sorry.
I'm assuming for it we
Question 2.
question 2. So I'm assuming that we take the shear stress, right? And we take the what's it called? It says how to find the strain, right? Or no, my bad, the length of stress. So I think when we do the second stress would be 0, I'm assuming. And I think it's like if you plug that in to the radius equation, and the radius is if less than, alright, so if it's less than the ultimate shear, which is what we already found, I think, then there's no failure.
I'm just gonna try that.
Okay, so what part did you get? What part did you get for this?
I clicked true.
So I'm gonna click false.
Oh, I got true.
Wait, oh, like you got it right?
No, I clicked true.
You got.
Yeah, I got it right here. I got that part.
Fuck. Dude, what?
What, did you not get it?
No, I didn't get it.
Not the second part?
I didn't get the first part.
Oh,
Wait. That's exactly what he said. Alright, let's get it again. How do you feel about the final?
I don't know. If I heard if I do how I've been doing all past, I guess I feel okay.
So I'm probably gonna go back up to like a 63 average.
Okay, that's fine.
What? What is that?
That's fine.
You do? Yeah. I'm just worried that like I might not be enough.
No, I think we'll be okay. We go to every class we try. You know?
Bro, imagine we get like a 30 on the final.
We're not, we'll be alright. Okay, I got this number. Then use tau plus.
No, that's for the rest of that. This is just asking us to find the shear stress, like the first part saying determine the shear stress at C. Right, that's the first part.
So this should be it.
Yeah. The other part is when it's solving for stress, right? That's saying, I think that's saying, what's it called? Like that's using it for the Moore circle.
You're right.
He said he got a double.
Oh, I did it.
Yeah, he said he got a double digit negative.
I got it. Yeah.
That's right, he's so smart, he's so bad, I suppose.
Ethan?
Yeah. Love him, kid.
That's great. It's good. So he didn't get 3 yet, right? Oh, I should. Why can't I just do? Oh, because there's a moment as well. Fuck. Oh my god, I don't want to do this shit.
Dude, I'm so burnt out. I can't do this forever, dude.
Yeah. I'm scared for calc.
That shit sucks. Are you doing Laplace transforms yet? Or you know, you're only like halfway through, right?
I only have 2 weeks left. I mean, 3 including this week, but I only have like 1 class and then 5 the midterm.
If you need help with Laplace transforms, I'm just pretty good at those.
I don't even know. Dude, okay, I can actually ask you.
Are you doing Laplace transforms at
I
all?
have no idea. I haven't been in class. So he said it's 3.16.
Laplace transforms are basically transforming
We're doing a bunch of vector stuff right now.
vector stuff. Okay. I go ahead and see if you're even gonna do those in the.
What would it be? Where would it be? I don't see anything. What are they? What's it about? I don't see it.
It's like solving. It's like transforming and solving. What's it called? Like complex multivariate equations. It's like you transform it into something into a different thing, but then you'll have to, and then you change it around, and then you do the kind of it doesn't act the same as a derivative or integral, right? But it's kind of like, imagine for a problem, you have multiple things that the way it's formatted, you just can't figure out, but you can't change it around anyway.
Yeah.
You take the derivative of something, right?
Yeah.
So that way, once you take the derivative, you can change it around a bunch, and then after you're done changing it around, you take the integral to revert it back,
Oh.
and then it's something different, which is able to be solved.
Okay.
That's a
Okay. That doesn't seem too
again
bad.
doesn't
But it's with imaginary
it's
numbers?
completely different, and it does not have the same effect, right? But it's like that's I guess the easiest way to explain kind of the process of the response.
Yeah, I see what you mean. Alright. Yeah.
Alright, ready for number 3?
No, I'm on it right now. Did you get to?
Yep.
Alright.
Just that high.
What's that?
Is my mark average just that high compared to what everyone else? The fact that I got a 30 in the first exam, and like an extra like 10 points from you guys on this exam, you might have got like your average.
I mean,
Like,
I'm. Let's see. I didn't do that much better than you in the first one.
I mean, I got a 28.
You did probably as much. Yeah, I was 63.
I thought I had the exact 63.
So you're about.
Huh?
Well, what's your? I forgot. I think I should break down. Yeah. What's your 7th grade?
I'm going up grades right now.
Let's go to the bottom.
My bad, I have a 61.
Oh, okay.
Assignment? Oh, yeah, the past week I fucked up on assignments.
What have you done?
I dropped it from like a 92 to like an 82.5.
Oh shit, really?
Yeah.
What's your attendance?
Attendance 100%.
Oh wow. You've been to every class?
Yeah.
You don't make parking tickets over there?
What?
You don't make parking tickets?
Yeah. You're parking the wrong car.
Did I ever even pay them yet?
Oh my god. I've only gotten one. I'm not gonna say anything actually.
One what?
It's not gonna work. I'm not saying out loud. I'll wait till after the semester.
Okay. Rutgers sucks.
Would you want to get together sometime so we can start studying?
You know we should. Yeah. I mean I have calc, so what do we what day would we do?
Yeah, this also I was thinking about it was kind of good for this. These were 5 units that we have to like add to an equation sheet for. Use the other 2 equation sheets we made.
Oh well, we'll get those back.
Yeah, I got mine back. So I'm saying we already have 2 equation sheets. We have 5 units instead of 10 this time. Put on a new thing. And did you use up all the space in the last?
I mean I can just have a sheet.
I'm just gonna go to all as many examples as possible throughout the week and just write down the examples. Like that's for question 1. I literally had the 2015 exam written down on my sheet, like every part, everything, like the entire process for question 1 for 2015, because it's almost the same thing as our question 1.
Yeah.
I had the entire thing written down already.
So I mean I only wrote one sheet to my second exam. So I still have 2 full ones. Plus what I was.
Oh, because you just
I
added.
don't there's nothing else I thought you.
Yeah.
Without like obviously going through and like copying 10 questions, but you know. But I'm gonna do that in this next exam because I have 2 full sheets. I can literally get down like I can get literally every single 5 question sheet if I wanted to. so when are we taking this exam? Is it 3 hours or is it in class? Is the final in class?
In class,
It is, okay.
2 hours.
Because I was gonna say if it's 3, then I'm not making my calc. Normally finals are 3 hours.
Well, that's what he was saying, where it's like the final will be a little lighter,
Yes,
and then like the last field, it won't be as long as UEC and stuff, because we don't have an extended time for it.
Yeah.
Oh, wait, you said you have, oh, it's on Thursday, and your calc is on Thursday, right?
The exact same day. Like right after literally 30 minutes left.
Oh my god, dude, that fucking sucks.
I know. Tell me about it.
At least it's
You
not
hate
the
it.
final.
You shaved too?
Who's this kid?
It's Black Death Rugby.
Well, I think I actually think the majority of my bloodstream right now is just espresso martini.
Wait,
17.
Fuck you. Honestly, fuck you.
What?
What?
What'd you get?
10.5.
13.5.
Still terrible.
It's better for that than the first one.
He didn't give him back yet. Don't go take it. He didn't give him back.
I just wanted to look at it.
Dude, I'm so pissed because I completely forgot to study the question 2, how it started out. Like
How does it look?
it was like the it looked like that.
Yeah.
Right? It was like you had to find the this question. It's like find the
Oh yeah.
like finding like the stress and components.
What was the problem?
Stuff like that. No, I'm just saying I completely forgot to study that unit. And the Morse
16, right?
It went right into the Morse circle. So I was like, are you kidding me? I can't do the Morse circle either. So I lost 7 points.
Wait, why did you take classes here this summer instead of like community college?
Do you think community colleges usually have
Engineering
like mid-level engineering courses? Not even the other Rutgers campus have this class. Yeah. You think I would really go to Rutgers Newark?
Yeah, no, you're right.
I remember my cousin's cousin, like her cousin from the other side of the family. He was an engineer, now he'd go to law school. He was like, yeah, I mean, I had to transfer in some credits from Rutgers, so that was a nice little break from what I was doing. I was like, Rutgers isn't easy, like, where did you go? He was like, oh, Carnegie Mellon. I was like, oh, fuck you. Like, he went to Rutgers to transfer credits in because it was easier.
There's no way other schools would like, they can't do that. Right? Like, there's
I
no
don't
way.
know.
Like, I know for damn sure that I would never be caught dead. Like I knew for like a Princeton or something.
I guess-
Shit.
Like, Alex, how goes like,
UPenn is a fake school.
I know, yeah, like,
some of them are just the name you go for. Some of them are actually like okay, you know,
But there's-
with a good
there's-
impression and
here's like a
UPenn's
word
fake
for it.
school.
What's it called?
There was white collar ivies.
Yeah. Oh, yeah, that's what it's, years ago.
And one of the
Like, there's no way that motherfucker. And he's probably paying like 90,000 a year.
But MIT, first math class you take at MIT goes all the way through calculus.
Are you serious?
It's
What's it
Yeah,
called?
it was like-
Intro to math?
It's calculus.
Isn't that is that the one I'm thinking about? Or was it one of the high-end schools in our country? It's like one of the maths you have to take is like one of the hardest renowned math courses in the entire like
Probably at MIT.
and it's literally homework assignments will take you anywhere from a full 20 plus hours to like 30 hours. And you'll be like, you'll get like
MIT is ridiculous. Their average accepted GPA is a 4.0 for grad school, like so from college.
Are you serious?
Bro,
That's ridiculous, dude. I don't even know.
like it is way harder as an engineer to go to MIT than it is as a lawyer to go to Harvard Law.
Yeah. Why?
it's like why would I
Like
even want
if
to
MIT was a law school, Harvard Law would be bad plan for the kids applying to it. Like, it's crazy.
God, I keep like.
Just like stuff like that, like if I went there like I'm just like doing it.
Alright, I can jump on. Great.
Well, at least the fridge would be Like the fridge wouldn't fall.
Yeah, you're gonna be standing. Did you guys get the question?
No,
I
I-
already
I-
tried like
so-
16 times.
I just wanna, once you get the 1 point that you get.
Oh yeah.
I go fine.
I suppose we have to do 23 the weekend as well. So how hard was 23?
Did you get any of them?
No, I was just playing bad.
You didn't get any of them?
2.
Yeah, question 1, obviously.
Obviously.
What do you mean it's a multiple choice?
No, it's not.
Good morning, George.
Oh, it's just 200 over the 2 that you got.
Really?
So like it's 100 and then you're 45, it's 200.
Wait, well, isn't it not the other way around? Because it's supposed to be, what is it? Wait, what is it? Isn't it 10 over allow? Well, it fails at 200. Okay, I guess it is. You do the failure over the total stress. So just add the 2 stresses together.
Well, subtract the 2 stresses and roll the negative, so they.
Well, yeah, that's right. Yeah.
Subtract them and then, or technically add them. Over 100 or 200.
200 over there.
200 over.
Michael was right. Good job.
Oh, shocker, I was right. Never mind, just do both.
Hey, Matt. Yeah.
Oh my god.
I didn't know the cost was, which is best was the kids for
No, what I was saying before, if I went to like a place like Kennedy, I always think about that. Imagine I wanted someone like that, but I'm like, yeah, I would say, I think about it like the amount of alcohol my body would consume. In that 4-year period, assuming I didn't drop out or fail out, the amount of alcohol that would go through my system over the course of 4 years could probably kill a fucking whale.
One of us in the MIT classroom would be like, if there was a kid in the retarded person. Like,
Yes, that would be it.
No, if you look at the cokehead, that fucking cokehead walker that like drops out of college on the first year,
On the first
sitting
year.
down in like a mid-level engineering course.
One of my sister's friends went to law school, was 2 weeks away from finishing her first semester and dropped out. And she paid for it. And my sister was like, why didn't you just finish? She was like, well, I wasn't going to go continue law school. So yeah, 2 weeks later, at least you would have the credits to get it. We decided to go back. And I had to retake all the classes.
Oh, yeah, exactly, yeah. At least you had a friend about it, yeah.
So 91 minus 56.
No,
You gotta add them together, so
because
Yeah,
you're
but
subtracting
negative.
and then.
yeah.
Oh, subtracting. Oh, so you add. Okay, I'm fucking stupid. So just bear with me.
Okay, then what's the press of this? So it's,
Wait, you said you got 2 doors, right?
no, just.
What the full that's like, number 3, I'm sort of 22.
My parents the entire weekend when I was doing work, they come in every 30 minutes and like, do you think you need that? I'm just like, yeah, fucking locks on my doors. Okay.
Shit, mine barely.
My parents always get mad at me for locking my door when I go to bed, but then whenever I don't lock it, they get it and wake me up in the morning for some bullshit.
Yeah.
And I'm like, like literally sometimes it's just to ask me like a question, like, oh, we're going to the store, do you want anything? And I'm like, yeah, I tried to work with 7:50 to ask me that. And they're like, oh, why do you lock your door? I'm like, why do you fucking think I lock my door?
What other reason?
They also never knock. God forbid I was cheating or something.
Dude,
With that,
that was I started locking my door at college because of that. It's see like when I'm like hammered and I come home from the bar or something like that, I'm like absolutely blasted. I just like don't feel like putting on PJs, so I just go to bed and I'm mistaken. And there's been occasions where it's like I'm so beat that I don't even like go under the covers. I just fall on top of the bed, and then You can imagine they knock in the morning, right? Because they're like, oh, we're going to get food in the morning. Then they open the door and it's got right in their face.
Dude, one of my friends, well, it was like his friend's door, like, cause it was shared, so it was like his other friend was like his roommate. And like my buddy's not friends with him, or not because of this, but he opens the door and then he lost his name, like he was out and he was just screaming, what the fuck is he? And then they open the door, like I wonder if he made it home, and they see him pop up and it's like, butt ass naked, and then like God walk out of that and butt ass naked. Oh my fucking God. He was just hugging up with the dude. And they were like, dude, he was like, yeah. Why is this how we're finding out?
That's quite a fun way to find out.
And then he beat up one of their girlfriends, so they're not.
Yeah, yeah.
They're like, why is this how we found
Wow,
out?
way
Why
to
is
find
it-
out.
You know you have a roommate. Who is this guy, by the way?
Yeah.
Like, how does like no one opinion? You're like, who is this fucking guy that's naked in our room right now?
There was there's a kid in the class above me, the class above us. He referred to him to college. He said he was hanging out with his friend. It's like this huge black kid. He was really good, right? He said he's really chill. And all of a sudden, one day he's like asleep, and while he's asleep, his roommate brought a guy into the room. And when while he was asleep, he woke up for it. It was like, what the fuck? And so he said he literally in the middle of the night, like he was like 5 in the morning at that point. Like he said he still hadn't got up, went to whatever place for dorming, changed rooms right then, had his friend pick up all his stuff, and then went back.
That is, it hurt.
It's like, yeah, I said that to my sister and she started getting pissed, like, I was so, imagine how it felt to be like, whatever, no, he was just doing this, like, he was like, I was doing this, he was like, no, I really had to go from me. I can see his face from my bed, and he's, while I'm asleep, snuck in the room,
Yeah.
started, and did that, I would do the same thing, like, that's a no right there.
Yeah, that was right, you're right there.
Thank you. What are you gonna do this next couple days?
God dang. How many questions
Just 35. No, there's 5. That's 5. Oh, there's twice.
I was like, is home stress too deep?
Home stress is too.
Wait. Hoop stress?
Is it not-
PR over T.
It's just 2. Alright, wait,
Yeah.
And that's sigma x, right?
I mean,
Correct.
I think that's why. Are you looking at the previous exam or a different one?
I want to homework.
Yeah, it depends on how I have it drawn. You can go either way.
I actually don't think it's probably too much.
guys looked at any of the past final exams yet?
What's
No.
up?
So, I don't know if you looked at any of the past finals yet.
No.
Fucking hell. Does anyone know how to do the pressure vessel one? Because I can't think of how I'm doing this wrong. What is the minimum stress on a pressure vessel? Is it sigma Y?
I think it's because it's higher, but when I say those statistics, we got one. This thing was PR over 2D. That's a small one.
Yeah, alright. Okay, so what's wrong with that? I found the factor of safety is 2.7 if you multiply by 3, it's 5. I don't know why I can't do this. God damn, that's
Okay, thank you.
For number 2, is the factor of safety not just the yield strength over sigma x minus sigma y?
Okay, let's take a look. This is for session
24, 3.
Actually, I think I have it here as well. Da-da-da-da.
Yep.
That's crazy.
Yep.
Okay, so for this one, so there's a question about, this is, I guess, session 23. So we have a cylindrical pressure vessel, right, with some pressure inside of it. Radius r and thickness t. Okay, so we can do this two ways. We can think of what is the shear strength of the material.
What question is that?
This is session 23, question 2. Okay, so there's a question about what would the safety factor be, and we're looking at failure due to maximum shear stress. Okay, so maybe we should first think about what is the shear strength of the material. Okay, what is the shear strength of the material, and what is the shear strength specifically in terms of yield strength, right? So in this case, we have a yield strength of that. Okay, how is yield strength calculated, or how is it measured?
When the object can return to its original shape.
Okay,
No
so
permanent definition.
It's right when it starts out.
okay, it's right when it's happened, right? And under what what type of loading is it performed?
Normal.
Yeah, it's exactly. So this is what you have. Right, where you have some force in uniaxial loading, right? And so we know that Sy is essentially this F max over the cross-sectional area, right? A. Okay, so on Moore's circle, what does this loading look like?
Like a regular circle? All the way to the right?
Huh?
All the way to the right? Regular circle?
Okay, well I agree. So let's put this there. Okay, because it's a sigma, right? It's a normal stress. So that point's there. What are the other stresses? What are sigma y and sigma z? If this is sigma x, right? Let's say that sigma x is equal to sy. Sigma y and sigma z are
There's no shear stress.
0. There's no shear stress either, right? So we could say that if this were the sigma x, or we could say this is sigma 1 really,
This is just
sigma 2 and sigma 3 are at 0. So what is the shear strength of this material now? What's the maximum it can handle?
Sigma y
Well,
or Sy.
not exactly. No. What's that? Let me ask the question a different way. What's the absolute maximum shear stress this can handle?
Sigma 1 over 2.
Yeah, that's right. How did you get that? You got that because you drew the Moore circle, right, in your head, and you said this is the radius, and this is the absolute max, right? Right. So Sy is equal to R, which is equal to sigma 1 over 2. All right, which is equal to Sy over 2. So to go from a tensile test to a shear strength, right? A tensile test that tells you the yield strength to understand what the shear strength is, SSY, we look at Mohr circle here.
And SY is going to be PR over T.
Okay, so now the other thing though, sigma H, all right, this is the hoop stress. Okay. Sigma H, as we said before, is PR over T. Okay. Same thing applies though, right? Where we're looking at a Mohr circle, right, where we have PR over T. We actually have a PR over 2T, okay? And we have sigma 3 equals 0, right? Because this is the hoop, this is the longitudinal, right? This is I could draw, we'll just say sigma L or sigma 2 is what often is written, okay? And sigma 1 is the PR over T. So once again, we have to look at the Mohr circle. In this case, yeah, R is going to be PR over 2T again, right? So the tau absolute max is PR over 2T. Okay. So what is the safety factor? Well, the safety factor, right, is going to be whatever you have for your SY, you're going to have your SSY, the yield strength, right, divided by the absolute max, like that. Now, if this, if this thickness is too small, right, then this, if the absolute maximum is above the SSY, then we're going to have failure, right? So we need to multiply the thickness by an amount to make these two quantities equal to each other. Okay. And if there's a safety factor, like if they want us to have a safety factor that's higher than what we have, we'd also still have to multiply the thickness. Okay.
internal outer external radius?
Wait, what's that?
For two, it says radius, the internal outer external radius.
Oh. Yeah. I have no idea. I thought I did it and then I didn't. So isn't T absolute max just P over 2T?
PR, okay, PR over 2T needs to equal.
Right? Isn't T absolute max P over 2T? So then how is P over 2T? Like,
It's saying, okay,
it would just be one.
you use the stress H, right, the stress of group. Use that equation, because PR over T is equal to theta 1.
No, I get that.
Wait a second.
No, you can use
Yeah.
pure 2T.
And then you do that to find SSY.
SSY is constant because it's.
Yeah. It's constant.
SSY is just P over 2T.
could change is.
Yeah, exactly.
Okay.
And then
What's
we
T
have
absolute max?
S5 or SF is equal to the yield strength of
Is equals 5.
yeah, it equals 5. So multiply the max, right, by both sides and divide the whatever. So it's really max equals the stress over 5. And then, so it's PR over 2T equals 5. So we have P and R. So when we
Also.
well, yeah,
Yeah, we'll solve that, yeah.
we figure out what that's like what T would need.
Yeah, it's like later there. And treat the raise as internal.
Alright, am I crazy? Why is this not working?
Yes.
I can't figure out why this is wrong. Because the fact that they figure 200 over PR.
Well, I don't know the exact numbers that you have, so the yield
Well,
strength is
then
still.
push it through it.
Right.
When I did some, it worked with just P over T, not 2T.
Well, it's
Well, it worked for me.
we need to still multiply by a safety factor of
Yeah.
5.
Yeah, that's why.
Right.
Still, I use T as well.
Like
Well,
T here.
Yeah.
Well, you still use. Yeah, well, that will work fine, because that's the yield strength, right? If you compare, so,
Should I have this?
yeah, so, because it's, what I was trying to show is that you're comparing, it's asking you to compare through the, this is number 2? Yeah, so this is fine. That's perfectly fine. If you're using the shear strain criteria,
Yeah, that's what's great ones.
if you're using the shear, so you have to, if you do PR over 2T, then you have to divide the top by like 2 as well.
You get a very high.
Because you're comparing, so it turns out, right, that if you compare
I didn't use X.
shear strengths,
200
That's
why.
is the yield, exactly, right? So if you had to divide both by
So we
2,
need to find.
or
we need to find
you would, or you can
Oh, yeah,
kind of
you
leave
can
it, or you can leave it,
absolute max
right?
and the stress factor, right? Safety factor. We're given a safety factor that we need to like.
Right, is that good? Are we good?
Oh, yeah, I
Okay.
just wanted to help you.
Yeah. No, that's good. I'm glad we're talking.
Sigma 1 over 2. that
wait,
then
no,
sigma one over
Good.
2 is equal to sigma h.
Yeah, I just wrote, I put the paper, we're giving yield strength.
So
Yeah, so in this case, the factor of 2 affects both the yield strength and the
I get the nod, I just
Yeah.
wanna-
calculated maximum
Yeah.
stress that you have.
Okay.
Yeah.
Yeah, makes sense. I can see it now.
Yeah. Okay.
If you were to yield strength, that's-
Oh.
That and then you
You guys solve for 2 related to these fields, right? I'm assuming you solve for 4 divided by the and then use 2 you just got over what this curve is that is saying which is the 5 you need to multiply what we have here with this about this.
Well, guys, really, I was using the wrong one for this stuff. I'll try it, because I'm trying the equation without that, because I assume A.
Where on the website is the answer sheet for the equations, for the exams?
It should be.
Oh, is it SU? Oh, yeah, yes, yes.
I don't know what I'm doing on the keyboard. I think I'm just-
No.
Yeah.
You need help with number 23. Or number 2.
No, I got it.
Do you guys any questions?
So, the criteria for maximum shear stress is always gonna be equal to maximum stress.
Right, so when we,
The safety factor is always gonna be the same, those two.
if it's maximum shear stress, right, if that's what they're asking us to compare it to, yeah, then we're always looking at calculating out what the maximum shear stress is, and yes, if they give us a yield strength, you have to divide by 2.
No, I'm trying to.
Because the yield strength was calculated under uniaxial.
Well, it's just a matter
They're
of
always the same.
answer is
Same.
anything, it's a fact.
What do you mean by they're always
How
the
much
same?
multiplying by?
I don't know.
Yeah, it's just no meters, as long as
maximum-
everything's in the same meters.
Basically, what
everything's
you just
same.
did, the
That's
SSY
That's little.
or T absolute maximum
Yeah, I know.
Okay,
It's always gonna be the same.
to SY over
It's easier.
the,
This is always,
Like that.
okay.
this
Yeah,
is
I'm
always,
trying to equation.
that one is always, right, that the shear
Like how I
strength,
phrase it.
right, is always
So-
gonna be the yield strength over 2. That at least,
So it's.
if it's through, maximum, shear, like, the maximum stress, maximum shear stress criteria. Okay, there could be other criterion that you'll see that we use that, look at things a little bit different relative to just the yield strength. You're like Von Mises, for example, right? Where you're looking at maximum distortion energy theory, and so it comes out, you're comparing to this, right? Instead of comparing to this, okay, for that criteria. But it depends on the loading, right? If you have different types of loading, alright, it may not come out to be just like this. For example, right, if this is a spherical pressure vessel, right, then it's going to be, like you pointed out, on the groupie, right? Then you have your more circle would just be PR over 2T, right?
Yeah, with the absolute
And then
max.
the absolute maximum shear stress would be PR over 4T, right? So then you compare that one to this. Does that make sense? Okay, yeah. Sure.
Like I said, like,
It was 23.
The one that's for today, or
Mises criteria?
Mises, Von Mises?
Always Mises.
Von Mises, yeah. is session 24, right?
It's 20, no, it's
That's.
Oh, 23, okay, yeah.
And then big for
Right,
that.
because your current group stress,
Yeah, there it is. Yeah.
that is what your.
Do I need to?
Yes.
That's when you have.
You can use that.
Well, you
That's
might
fine.
use also.
You're gonna need that
Is
as
this
a
what we
variable.
want?
Yeah, but you had to, or do you need to calculate Zoom equivalent? Yes, you do. For long meetings, you can be able to do that, that's correct.
No, yeah, I know, those are the.
And so you could do it this way, but this way you have to solve, sometimes you might have to, yeah, you can do this, how do you put it? You have to, calculate sigma 1 and sigma 2.
Stress C is almost gonna be 0. I feel like we're not,
Are you talking about that?
Yes, so it's nice to have it all out,
Alright.
right? This is a useful format. I would write these down, yes. You can write this one down too, that's fine, but, these guys are pretty critical. And you know, if you don't wanna write that down, that's fine, write that one down, because you gotta, as long as you can get the sigma 1, sigma 2, sigma 3, right, you can use that one.
Yeah, useful.
Yeah.
Is that the yield stress?
Is the maximum stress that you possibly take, right, over the issue of stress you're actually using, right? Or if it's sheer.
So did you get more?
No.
If you know normal stresses though, how do you build more stress?
You guys something like 5 or 2, right? Is that, you guys something like 5 or 2. Where you don't make from ratio to that. You remove my bikes, that one factor was fine. You're just doing that, you're just going to know what factor you want, and is it just 5 or 2?
I'm plugged in for that.
Oh, you solve your.
Plugged in for the current,
Yeah.
plugged in, that fits.
So then you can solve for the new statements and that stands for the new statements, or is it by multiple?
So, I'm not sure. I didn't close that.
Okay.
I plugged in current into that.
Okay,
It's isolated this,
yeah,
right?
yeah,
And solved for this variable. So we have P, we have PR, both of these.
yeah.
I plugged in that statement of variables that solve for that. So that's what we need. This is what we have.
Yeah, that's
You
what I
then
did
do
for this, yeah.
This over, you do what we need over what we have, and that's saying, okay, so if we want the factor to be 5,
Mhm.
we need to multiply
That like 2.
that over that, right? That number, that factor. We have to multiply that by
Like 2.5, right? That's the factor Q. So the new, T1 is the new, T0 is the original. We have this on top of that.
So 5 over 2 is the answer.
Last time when I did it, it said that, that's why, I don't know if those triggers. Yeah, I was gonna do the other one, method about that, this is, what I do with that.
Oh, I forgot one thing. I forgot if you look at SSY, square equals the 2.
Mhm.
So it's technically group stress over 2 is equal to the SSY.
Okay. Well, shoot, we're to- So the over 10.
We don't track finals, yeah, so you know, the previous finals were at like out of 40 points or something like that, or 30 something or whatever. We don't have 3 hours on Thursday.
What?
for the final exam. We don't have 3 hours. Normally those final exams are 3 hours long. So it's going to be shorter. Which means it will probably have even more emphasis on the latest material than,
Is it still gonna be like the 3-question format?
I don't know. I'm thinking it will probably be, because we have a time constraint. It may be a little bit longer because the 3-question format is usually what I use for the 80-minute class. So we have an hour 50. We have how many minutes? Yeah, we have 115 minutes versus 80 minutes. So we've had extra time on the previous ones. So maybe but something in between probably.
Plus,
Sneezy this morning.
I was sneezing this morning too. I don't know what it was. I got over it eventually, but I was sneezing.
Shows it under moderation.
We don't have classes tomorrow, right?
No one is. If you want me to be here, I'll be here. All right. So that's the thing. If you guys want me to come, we can do what we normally do. And if you want to DM me and say I really want you to be here, then I'll be here. So far, I haven't received one of those. Okay. Huh? So.
What about Wednesday?
Wednesday I'll here for sure.
Going to any barbecues tomorrow?
Huh?
Going to any barbecues tomorrow?
Am I going to any barbecues tomorrow?
Actually, I wanted to go out with my family, but we got the finals.
I'm sorry.
Yeah.
Yeah. I don't want you to feel guilty about. So if you want me to be here tomorrow, I will be here tomorrow. You want me to do that? Okay. I think it's out of affection that you said that.
It's 4th of July.
It costs me $15 to get here.
Huh?
It costs me $15 to get here.
Oh, okay.
Your family needs you more.
Thank you. Well, so
Your family needs you.
11.7.
What is your seat? Easy.
236.
3.5. 30.
Just right.
I need to. What is it? Maximum social measure.
that's for your benefit. The assignment that we have is still due tomorrow.
Okay.
Okay, because I don't think you want to delay it because we're ticking down to the end. So do it tonight if you need to do it.
Is it important?
Yes. Oh no, well don't do it because it's recording still. So give me a.
It's not like, it's not that person, it's just about the regarding stuff.
About what?
The report.
Oh, okay, yes.
About your research.
Yeah.
And all that, yeah. So, did a little research about some points.
Okay.
So it's pretty cool.
Yeah.
What was your research about again?
So
Some components.
Yeah, so we've done kind of we were involved kind of in the earlier phases of soft robotics with pneumatics, but now we've been doing more with what we call elastic robots. I'm still interested. Yeah, I think so. I personally think that one of the interesting areas for using a lot of soft materials is in aquatics. Okay, so for hydrodynamics, for robots of that nature. There's still applications, of course. And,
Like, can you give me one example?
yeah, so we've done some work with jellyfish, looking at, not live jellyfish, but looking at jellyfish-based robots. So we didn't publish a paper.
I saw YouTube videos about like hands, but they look like jellyfishes.
Yeah.
They grab stuff with jellyfishes hands.
Yeah, so
You guys don't need
like that, some of that came out of Harvard, Rockwood. So we,
How's your math?
if you look at, so if you go on the Rutgers repository for species, you'll see that we have a few master species on jellyfish locomotion. So the Beery, some other people had funding to look at jellyfish as efficient aquatic locomotors. And so even though they're slow for their mass, they are some of the most efficient swimmers that people have found. So there's like a 2014 paper in the Proceedings of the National Academy of Sciences, PNAS, where they talk about the cost of transport, which is essentially a measure of how much energy you have to expend for a given amount of mass, for a given amount of distance traveled. And jellyfish do very well for their size. So we spent a lot of time with master students, master species at least, looking at how to make synthetic jellyfish. We're actually working on that a little bit again.
Oh, I'm seeing.
Huh? Here at Rutgers, yeah. And
You said Rutgers?
Huh?
You said Rutgers? Rutgers.
I say Rutgers.
I'm not supposed to say Rutgers.
Yeah.
I say Rutgers.
Yeah. So, if you're interested in that, I mean, we have another undergrad who is interested in eels right now. So looking at maybe eel locomotion. This is an area where more soft materials I think will be useful. We're also looking
What kind of masters should I get to get involved into that kind of robotics?
Well,
Is that mechatronics
yeah. So
or it's more like
for masters,
solids? Sounds like solids, fluids.
yeah. So that's an interesting thing. So a lot of this soft robotic stuff is very interdisciplinary. So it's really
Fluids, right?
So if you're doing stuff with aquatics, with hydrodynamics, yeah, then fluids is very important. And understanding how the flows affect propulsion, that's extremely important. A lot of soft robots is
That's not
really
gonna be
mechanics,
actually
though,
stash
like
all
you're
day.
getting to. And then other aspects are controls. I think we talked about this before. So controls, and then you have the electronics connected to it.
Basically, I want to get my master in mechatronics.
Okay.
Do we have mechatronics in here? I saw that we do have
Yeah, we
robotics.
have. Yeah. We have.
How good is
Because
should I?
because of this equation right here.
Okay, maybe I'll ask you this.
Yeah, maybe we can talk about that afterward. How's that sound?
That's where we.
Alright.
Yeah, let's talk.
We messed up this equation. Let's use these calculations. Trying to get myself on the same process, just
Don't do that. That's not doing that over there, it's gonna fall half of that.
It's going there.
And you said
PR over.
Huh?
I haven't been to. So I did cow swapping like that. So PR over. This value. Well, you don't have German, correct? And then I'm talking about two.
Not trying.
Actually, is it time? Oh, it's time. Let me close this down. Thank you, everybody, for joining us today.
So I go to class today to be boss, right?